Hey there, fifth graders. So yesterday we took a look at what happens when we multiply numbers by powers of 10. And remember, powers of 10 are really special numbers. Powers of 10 represent our place values, and those include numbers like 10, 100, 1,000, 10,000, so on and so forth, etc. So this keeps going. So when we're multiplying by numbers like this in particular, some really nice things happen. And again, these are powers of 10 because these can be represented by using exponents. So remember, 10 is 10 to the first, 100 is 10 squared, 1,000 is 10 to the third, 10,000 is 10 to the fourth, so on and so forth. So we multiplied by powers of 10 yesterday, and we noticed a nice pattern that when we multiply by a power of 10, we tack on the same number of zeros as the power of 10. So if we just kind of think about the fact that we're going to be dividing, we might be able to make just a prediction that maybe instead of tacking on zeros, we're going to do the opposite, which is removing zeros. So that's kind of my theory and my prediction, but let's go ahead and actually do the math and see if that ends up being the case. So I'm going to set this up for some long division. Let's start in standard form because I know that you boys and girls are rock stars at long division. You worked super hard at that last year. Now this first problem, we don't necessarily need to set up for long division. This is 20 divided by 10. I know 10 goes into 20 twice. So that's 2 times. If you want to set up long division, that's fine. I'll set up long division for this next one. 200 divided by 10. We can use our brain and figure that out. We can skip count 10, 20, 30, 40, 50, 60, 70, 80, all the way up to 200 if we want to. That's a little time consuming. So let's go ahead and set this up for division. And before we do that, let's label the parts of a division problem because it's really important to know which number goes into the long division symbol and which one goes on the outside. So your first number is what we call the dividend, and that is the number that's getting split up. The second number is what we call the divisor, and that is the number that you're dividing by. So it is always the case that you put the dividend into the, and you're going to hear me call it the doghouse. I don't know, I just envision that as the doghouse. I know some people say the longhouse or just under the division symbol. And we are dividing by 10. And so now I'm going to use my long division skill. So the first number I'm going to look at is this 2. I'm asking myself, how many times does 10 go into 2? It goes in 0 times. I'm going to use that 0 placeholder so everything stays lined up. How many times, now I'm going to stretch this out. How many times does 10 go into 20? It goes in 2 times. I will multiply and subtract. 2 times 10 is 20, so I subtract 20. And now I bring down my 0. 10 goes into 0 0 times. So the answer here is 20. And it is true that 200 divided by 10 is 20. Let's look at 2,000 divided by 10. So again, this first number goes in the doghouse in the division symbol. The divisor, the second number, goes on the outside. 10 goes into 2 0 times, but it goes into 20 twice. I'm going to subtract 20. Bring down my 0. 10 goes into 0 0 times. And I could subtract 0, but I'm just going to get 0, so I'll bring down that next 0, and it goes in 0 times again. So 2,000 divided by 100 is 200. Okay. So right off the bat, let's go ahead and just kind of analyze. So I had 20 divided by 10, that gave me 2. I had 200 divided by 10, it gave me 20. I had 2,000 divided by 10, and it gave me 200. So kind of right off the bat, I'm noticing something interesting, that it looks like I'm removing a 0 from my original dividend. I'm removing 1 0 because I'm dividing by 10 in each one of these cases. So that's really interesting. Let's see what happens when we're dealing with numbers that aren't necessarily 10. So again, I'm going to continue with my long division. So I have 200 divided by 100. 100 goes into 2 0 times. It goes into 20 0 times, but it goes into 200 twice. So this answer is 2. The quotient, which is the answer to a division problem, is 2. 2,000 divided by 100. Well, 100 goes into 2 0 times. 100 goes into 20 0 times. 100 goes into 200 twice. I'm going to multiply and subtract, and I bring down a 0. 100 goes into 0 0 times. So my answer is 20 here. And now I'm going to divide 2,000 by 1,000. So now we're getting even bigger. 2,000 divided by 1,000. And again, I'm going to take it digit by digit. 1,000 goes into 2 0 times. 1,000 goes into 20 0 times. 1,000 goes into 200 0 times. 1,000 goes into 2,000 2 whole times with nothing left over. So our answer is 2 here. So again, let's go ahead and take a look at the number we started with and what our quotient ended up being. And we'll also analyze the number that we were dividing by. So these stayed super similar. So I'm dealing with a 2 out in front with all of my quotients. And again, quotients are answers to division problems. So here I divided by 100, and I'm noticing that when I went from 200 down to 2, I eliminated 2 zeros. And that's pretty interesting that there's 2 zeros in 100. I have 2 zeros in 100 again down here. Oh my gosh, and look at that. We eliminated 2 zeros to give us our quotient. Let's see what's happening with 1,000. 1,000, we have 3 zeros. I'll kind of point that out. We have 3 zeros, and when we did the long division, so this isn't just magic. I'm proving to you, using my long division that everybody's on board with, I'm proving to you that that was the answer. Now I'm just noticing something interesting, that there was 3 zeros here, and if I actually just eliminate 3 zeros, I'm left with what my quotient was. So this actually is not a just a coincidence. This is a nice little math trick that we have. And it does turn out that when you divide by powers of 10, you can simply eliminate the number of zeros, the same number of zeros as the number of zeros in your power of 10. So we're going to summarize that down here. When you divide by powers of 10, again, this is only by powers of 10, such as 10, 100, 1,000, 10,000. You remove the same number of zeros as the power of 10. That's your divisor. So this does not work. I want to clarify. This does not work if I'm just dividing by 5 or if I'm dividing by 500. This trick only works when you're dividing specifically by powers of 10 because, as we mentioned, they're really powerful numbers that represent our place values. So let's go ahead and take a look at exponential form now and see what happens when we're dividing by these kind of scarier looking problems. If I showed this to you on the first day of school, I think a lot of us would have been intimidated, which means kind of scared. But the good news is we're feeling more confident with what these powers of 10 represent. So we're going to use our previous knowledge to do these division problems, and then we'll see if there's actually an even easier shortcut when we're dealing with exponential form, which deals with exponents. So I know that 10 to the first power is just 10. That's just a single 10. So 20 divided by 10 is 2. Now 200 divided by 10 to the first power, well, again, I know 10 to the first power is equal to 10, so I can just rewrite that as 10. And now I'm going to use my previous trick. So 200 divided by 10, I have 1 0 here, so I'm going to eliminate 1 0, and my answer is 20. And that is true. If you want to set up the long division, oh my goodness, we actually already did the long division over here, and our answer was indeed 20. 10 to the first power, again, is still just 10. I'm going to use my previous trick. I have 1 0 here, so I will eliminate 1 0 from there. Our quotient, which is the answer to a division problem, is indeed 200. And again, if you're not convinced, here's the long division to prove that to you. Let's take a look at 10 squared. So I know 10 squared is 10 times 10, which is 100. It's 1 with 2 zeros. I have 2 zeros here, so I'm going to eliminate 2 zeros there, and that is indeed my quotient. So I have 2 zeros, so I eliminate 2 zeros. 10 squared, again, is 100. I have 2 zeros, so I will eliminate 2 zeros, and my quotient is 20. If you're not convinced, you can look over here. We did 2,000 divided by 100, and we got 20. 10 to the third power is 1,000. This has 3 zeros, so I can eliminate 3 zeros, and my quotient is 2. If you're not convinced, look over here. We did get the quotient of 2. So I want to examine, which means look at, I want to examine my exponent and how many zeros I was eliminating. So it turns out I actually did more work than I needed to. I don't even necessarily need to write these out in standard form. I can just use my exponent. So my exponent tells me how many zeros I will be eliminating. So if our power of 10 is written in exponential form, there's an even quicker shortcut. If it's written in exponential form using those exponents, you remove the same number of zeros as the exponent in your divisor. So let's do another example just to clarify what that means. So if I have, let's say, 500,000 divided by 10 to the fourth power, I know that 10 to the fourth power is going to have 4 zeros in it. So I will eliminate 4 zeros. Oops. 1, 2, 3, 4, and my quotient is 50. It makes the problem much quicker and much easier to solve. Let's do a couple of practice problems on the back to solidify these shortcuts. So again, I summarized what's going on. So when we divide numbers by powers of 10, we are going to cancel out the same number of zeros as the number of zeros in your power of 10. So 1 0 if you're dividing by 10, 2 zeros if you're dividing by 100, 3 zeros if you're dividing by 1,000. And if it's an exponential form using exponents, you cancel out the same numbers as the exponent in the power of 10. So 10 is 10 to the first power. I'd eliminate 1 0, 2 zeros, 3 zeros. So let's do some practice problems. This has 1 0. So I eliminate 1 0, and my quotient is indeed 24. If you want to set up the long division to check my work, go for it. Here I have 2 zeros. I eliminate 2 zeros, and my quotient is 43. Here I have 4 zeros, so I will eliminate 4 zeros, and I'm left with 7500. I throw in my comma, 7,500. 3 zeros, so I eliminate 3 zeros, 1620. And I have 1,620. So this is what's left over, which is now my quotient. Let's do a couple powers of 10. This has 2 zeros. So I will eliminate 2 zeros, and my quotient is 50. This has 3 zeros. I eliminate 3 zeros, and I get 34. I want you to go ahead and try these last few on your own, and then you can check my website for the answer key to ensure that you are doing it correctly.